In this presentations, we are going to discuss about the kernel IO subsystem in operating system. This is the kernel IO structure. So actually the hardware and softwares have more responsibility in the computer systems, where the software process has many drives to active the hardware. So the kernels is a main heart of the subsystems in a software. So it make all the process and control to the hardware. The characteristic of IO devices. So in this data transfers modes, so it has the characters block and the examples, the terminals and the disk. So in this access method, it is in sequential random modern CD-ROM. So like that, each IO devices has each characteristic. So the IO directions is in the read only, write only and read write. So in CD-ROM, graphics controller and disk. So the IO devices hardly derived and activated by the device controllers. So broadly the IO devices can be grouped by the OS into block IO, character IO, memory mapped file access and network sockets. For the direct manipulations of the IO device, specific characteristics usually an escape block door and the block and the character devices. So then this block devices include a disk drive. So that's the commands include read, write, seek, and the raw IO and direct IO or the file system access and the memory mapped file access possible. So and the DMA. So here the character devices include the keyboards, mic, serial ports. So here the command include get and boot is used for perform this characteristic, and the library layers on top allow line editing. So in this network devices varying enough from the block and character to have own interface. So examples in the Linux, Unix, Windows and many other includes socket interfaces. So it has the select function, where these approaches vary widely for the pipes, first in first out, streams, queues and mailboxes. So the clocks and timers, so provide the current time, elapsed time and timer. So normal resolutions about 1 per 60 seconds. So some systems provides the higher resolutions timer. So programmable interval timers is used for the timing and periodic interrupts. So this can be performed by the subsystem called the IOC3L. So it is used for this timer. Non-blocking and asynchronous IO. So in this blocking, non-blocking, asynchronous IO devices. So here the blocking process suspended until the IO completed. So easy to use and understand. It is an insufficient for some needs. So in this non-blocking, IO call returns as much as available. So here the user interface and data copies are involved. Then they implemented via multi-threading and returns quickly with the count of bytes read or written. The select functions to find if the data ready, then read or the write to transfer. So in this asynchronous mode, the process runs while IO executes. So it is a difficult to use. Though in this IO subsystem signals process when the IO completed. So in these two IO methods, there is an asynchronous and synchronous is compared. So here the kernel users have the request to access the process. So in that time it is in the waiting stage. So it access the device driver and the interrupt handler handle this interrupt signals which is given by the users. So in that time the hardware data transfers functionality is given to that acceptance to the request process which are waiting. So but in this asynchronous parallelly that request to be handled at the same time, and the undergoing there's a processing concept is also executed. So in this vector IO, it allows one system call to perform multiple IO operations. For example, the Unix read accepts a vectors of the multiple buffers to read into or write from. So in this read device is accept many requests for both read and write. So this scatter gather method better than the multiple individual IO calls. The kernel IO subsystem, so it has main functionality that is scheduling, buffering. So in this, scheduling is essential because some IO request ordering viva per device queues. So some OS strive fairness. So some implementations quality of services is an essential. So in this buffering, the store data in memory while transferring between the devices. So in this double buffering, two copies of data. So here that is used for the kernel and the user, varying size and full being processed and not full being processed. So the copy on write can be used for efficiency in some cases. So in this the device status tables is used to maintain the information about that it's a busy and the waiting state. So based on the request and the time, it can be in processing or waiting states. If the process is in the processing state, the input device is in the waiting state. Sometimes if it isn't ready to accept the input request, so in that time it going to process. So in that way the device transfer states are increased. So in this kernel IO subsystems is also support the main concept of the caching, spooling and device reservations. So in this caching, this concept is used for the fast accessing. The copy of data is copied to the cache memory. So in this spooling, the hold output of the device. If the device can serve only one request at a time, so it is in the processing. The device reservations provides exclusive access to a device. So in this error handling is also efficiency in the process management. So the OS can recover from the disk read device unavailable transient write failures. So retry a read or write, for example, some systems more advanced. So in this most returns and the error numbers or code when the IO request fails. So the some systems errors logs hold the problem reports. The problem reports is make the corrections afterwards. So in this IO protections is also essential to manage the IO systems in the efficiently. So the for the user process may accidentally or purposefully accepted to disrupt normal operations via illegal IO instructions. So use of the system calls to perform the IO request. The first tap to the monitor to perform the particular functions. So that case in the end, so it is going to the read process. So in that time it perform the read operations from the input device, then it return the output to the users by the return call. So afterwards the process continue the existing process. So in that time it is in the scheduling and the process uh, mm, executions to be handled in the kernel mode. The capturing of input and returns to the users done in the user mode. So in this kernel data structures, the kernel keep state information so for the IO components including open file tables, network connections, character device state. So these three kind of tables are used to maintain the IO components and its structures. So many complex data structures to track buffers. So it's a memory allocations dirty blocks. So some use object oriented methods and the message passing to implement this IO in the efficient, because the Windows uses a message passing. So here the IO information is passed from the user mode to kernel mode. So the message modified as it follows through to device drivers and the block to process. So in this Unix structure where the IO kernel structures are described, and the power management is a major concept. Here it is a not restricted domains of the IO, but much is IO related. So the computers and the devices use electricity, generally heat frequently and required cooling. So OS can help manage and improve the use. So then the cloud environment move the virtual machines between the server. So in this power management, for example, when implement the Android, so understand the relationship between the components and the system's buses and device drivers, and build a device tree for the representations like that. So power collapse can be done, so that also managed by the marginal power use, and the awake when is in the usage. So in this life cycle of an IO request, that it describes how the IO is request from the user sides, and it is how can be described and evaluated by the processor, and it is how to return the result to that user mode. So in the streams is a full duplex communications channel between the user level process and a device in Unix systems. So in the stream consists of a head interface and a drive end interface, or zero more stream models between them. So each model contains a read queue and a write queue for perform both read and write operations. The message pausing is used to communicate between the queue. So you have to maintain the flow table. So by using the flow control options that indicate the availability or busy. So the stream structures is, in the user process, the stream head has the read queues and the write queues. So in the stream head, the process of the intentions goes to the write queue. Afterwards, it is completions of the write operations. The device is ready to perform the read operations. So that is make a read. So the performance of the IO systems is measured by demands of the CPU to execute the device drive kernel IO codes, and the context switching due to interrupt and data copying. Network traffic is especially stressful. So the intercomputer communications is done in the serious manner. So how improve the performance by reducing the number of context switch and reduce data copy, and reduce the interrupts by using a large transfers, and use the DMA that is used for the large amount of transmissions. So use the smartest hardware device, the balanced CPU, and move user mode process. So in this device functionality progress, the applications and network and interactions layers are the more responsible for the data transmissions, where it can increase the development cost and increase the abstractions. At the same time, increase the efficiency and increase the timing. Thank you.